not it.
It's visible now?
Yes, now it's visible.
Yeah. Okay. Good evening, everyone. It's a true pleasure to welcome you all to TIECONN's eighth webinar, part of our mission to empower and uplift the global engineering community. So we are thrilled to have engineers and professions joining us from across Middle East, India, and beyond. So let us go with a quick agenda. We'll see the introduction about TIECONN and vision, mission. What is the vision and mission of TIECONN? And we'll meet the leadership team, executive and country, and what is our functionalities. And without not making much delay, we'll directly jump into the webinar. TIECONN stands for Technical Innovation and Engineering Collaborative Network, a platform created by engineers for engineers. With a rapidly growing network of consultants, designers, professions, and students, we offer expert-led webinar and panel discussions, career mentorship and networking programs, a space for innovation, collaboration, and community. We believe that learning never stops, and together we go further. TIECONN is led by a passionate and dynamic group of professions committed to shaping the future of engineering. And our executive leadership ensures the strategic direction, while our country chairs drives the global engagement in Qatar, KSA, India, Pakistan, and Bahrain. Special thanks to the event organizers, youth leadership, technical advisors, whose dedication brings these webinars up to the life. And we would like to inform you, we have successfully conducted 7 webinars, starting from chilled water pump head calculations and facility management industries, effective fire protection, and selection of chillers, and electrical load calculation for high-rise buildings. All these successfully we conducted, and it was a very positive outcome which we have conducted till now. Yeah, and our topic today is decoding kitchen ventilation systems, design, compliance, and efficiency. This is a critical and often underestimated aspect of HVAC and commercial design. Whether you're a seasoned profession or a HVAC designers, today's session will deepen your understanding of performance, energy use, and standards compliance in kitchen ventilation. And we are incredibly honored to have with us a leading expert in the field, Mr. Anmol Prabhu, a chartered engineer and a HVAC specialist in deep expertise in kitchen ventilation system. Mr. Anmol Prabhu is co-founder of VariSave Technology, a platform focused on energy savings in commercial kitchens. He is also well known in face of ASHRAE and ISHRAE, having served in multiple leadership roles and contributing significantly to HVAC education and policy. Please join me in warming Mr. Anmol Prabhu. Mr. Anmol Prabhu, the virtual stage is all yours.
Thank you so much, Raghavan. It's a pleasure to be here. So what I would like to start the event with is asking 2 things to all of you. One is understanding how many of you have worked in a kitchen. Let me understand how many of you have worked in a kitchen or experienced any kind of kitchen ventilation projects. Please raise your hand if you don't mind. Okay, I see a few of them. Yeah. So one of the things which happens in the kitchen ventilation industry is that there's a lot of disparity between understanding kitchen ventilation, because it sort of culminates between 2 industries, which is the hospitality industry and the HVAC industry. So this is what we'll be talking about today, just to give clarification on. So first is, let's understand what kitchen ventilation is. Kitchen ventilation is nothing but it's a part of ventilation in HVAC which deals with the kitchen aspect of it and or the hospitality part of it. Here you have people working in the BOS, which is the back of the house, and also FOS, which is the front of the house. So this is what our kitchen used to look like long ago, where you used to use charcoal, wood, and used to use mud clay pots for the operation of it. Then we have moved to a more modernized kitchen where you can see that everything is made of stainless steel. Now, the advantage of having a more seamless and more unique looking feature like this is that it is much more easier to clean, it is less corrosive, and it is much more hygienic in these terms. So why do you need kitchen ventilation is what I
Hello.
often ask people.
Hello.
Okay, what is the reason I ask people? Victor, can you mute your mic, please? Thank you. So, what is the reason we need kitchen ventilation? First is to provide a comfortable kitchen atmosphere for the staff. If your kitchen is not comfortable to work in, your staff will not feel worthy of working there. They'll not feel unhappy. And one of the issue what happened in hospitality industry is that it has the highest attrition rate. That means you have a lot of people leaving the business because they're not able to feel comfortable in the surroundings they're working in. Second thing is working with safety. What do you mean by safety? Kitchen is an area where you have multiple, parameters which can cause fire. You have oil, you have electric, you have a lot of gaseous objects, you have all those combustible objects. So all this can catch fire. So this is the reason we need to have proper safety. So main thing what we try to do kitchen ventilation is effective removal of effluents. Every time you do some kind of effluent generation while doing cooking processes, that is when you're using a shawarma or using a dosa plate or using some kind of equipment, it releases a lot of effluent gas, and this has to be properly addressed. That is the reason this is the primary objective of doing kitchen ventilation. So what does it start with effluent generation? First, let's understand what is happening here. Heat is a primary ingredient in this kitchen ventilation. 50 to 90% of the appliance heat comes from the cooking process which is happening. So it's mostly convective and some of it is radiative. This plume contains a lot of food, fuel, and a lot of effluent generation happens. So every time you see some kind of equipment being utilized, you will see that there is a dearth of, tadka or kind of oil being generated in the atmosphere. The primary objective of kitchen ventilation is to capture, remove the effluent gas and treat it and exhaust it out. So now think what happens is people miss out on one part, which is they don't understand how to capture it. So when you're not capturing it, what is happening is it is spilling into the atmosphere of the working area. So what happens, you have a huge fire hazard if the oil deposit onto your false ceiling, and you can have a lot of problems because of that as well by hygienic standards. One other thing what happens is every kitchen equipment has a different type of heat rejection rate. That is, you have some percentage of it rejected in form of convective heat, some in the form of radiative heat. The other thing is exhaust hood can only collect the convective heat. It cannot collect the radiative heat. That is where the air conditioning system has to take care of the radiative heat. So let's understand what are the type of kitchen equipment we'll be looking at. This is where I try to educate the HVAC team. What all are the types of kitchen equipment you will see? You have burner ranges or your stoves, which are more bulk in nature. They use a lot of fuel, which is LPG, CNG, or any kind of gas. Then you have hot plates, that your grill plate, which are used for making meat, meeting, salamandering, or meat cooking processes. Then you have dosa, you have rotis, etc., etc. Then you have tilting equipment. Tilting equipment again are bulk kitchen equipment which are used for cooking processes of a large quantity. Like if I'm making dal for 100 liters for an entire staff of say, that is where I go the tilting equipment. Then you have once where you do all your French fries, you do frying of meat, or you type any kind of food basically. Then you have preparation material where you have chapati making machines, shawarmas, puffers, etc. Then you have steam equipment. What are steam equipments? Which uses steam for the cooking process, like for idli making, or it can be for making dim sums or momos or any kind of food which requires steaming processes. Then you have charcoal operated equipment like tandoor or sigidi or barbecue. Then you have food warmers, bain marys, and you finally have induction cooktops. Now, all of these kitchen equipment have a different category of process which requires. So you understand, ASHRAE has 4 main categories of cooking processes, which is you have light, medium, heavy, and very heavy or extra heavy. So all this equipment are categorized based on the type of heat rejection happen in the kitchen equipment. So basically, this is what it looks like. You can see there are multiple kitchen equipment where I've shown here. There is a range, there is an oven, there is a fryer, broiler. So you will see that there are multiple kitchen equipment which are generating vapor content as well as particulate content. And this content deviates based on the type of operation process you're using. That is, are you using it for gas or are you using it by electrical fired equipment? So first, let's understand what are the different components of kitchen ventilation. Now, the idea here is to understand what are the processes of kitchen ventilation system, because if all of this work in tandem with each other, that is, everything is working properly, then you will not have any kind of problem. Now, the best way to understand whether there is any kind of problem in your kitchen is by looking at the false ceiling. If there is a lot of oil in the false ceiling and deposition has happened of the oil on that, that means some system is not working properly. It could be the chimney, it could be the duct, it could be the blower. So what does it look like? These are what is basically component, that you have exhaust blower, you have an exhaust hoods, you have fresh air units, you have exhaust ducting, fresh air ducting, and grills. So this is what it basically looks like. You can see that you have an exhaust hood over here, exhaust hood over here. You have a kitchen equipment over here, which is dependent on the type of cooking process you're looking at. Then you have a makeup air unit, which can be evaporative air type. Then you have a ducting for that, and then you have grills being supplied in front of the hood. Then you have exhaust ducting, which is usually made of MS or SS. Then you have an ESP, which is a scrubber. This component can also be called an ecology unit, which removes all the pollutants from the cooking process which is coming through the duct. And then finally, you have a blower. Now, this is a basic setup I've given for the kitchen process for a general kitchen. Now, this can vary based on the type of operation, the type of budget, and the type of filtration required. Sometimes what happens is the client says, I don't have the budget. Like in India, the client says, I don't have the budget to put an ESP because the pollution control norm is not very, very stringent there. So they say, I will eliminate the ESP or the ecology unit. I will only go with the exhaust blower. Sometimes the chefs or the client says, I want a exhaust hood, which is very, very premium type, which can have a lot of heavy filtration requirement there. That is, this exhaust hood will have a UV lamp in it. It will have high intensity lighting in it. It will have fresh air plenum coming through the hood, which will supply fresh air for the staff working underneath the exhaust hood. Then you have different type of fresh air unit as well. You have evaporative air cooling type. You have a TFA. You can have a IDEC. So it depends on the type of kitchen equipment you're working with. So let's understand them one by one. So first is the exhaust hood. A lot of people don't understand is that exhaust hood is not just a box. It is one of the critical aspects of the kitchen ventilation system. So by compromising on the exhaust hood, you compromise a lot on the system performance itself. So basically, ASHRAE, what it says is there are two types of standards. That is for ASHRAE type 1 and ASHRAE type 2. That is ASHRAE standard 154, which is for kitchen ventilation. It says that there are two standards for kitchen ventilation exhaust hood, which is type 1 and type 2. Type 1 is wherever there is oil or grease or smoke, there you go with the type 1 exhaust hood. Wherever there is an absence of this, you go with the type 2 hood. That is for steam, vapor, or just hot air. So wherever there is oil, then you go with the type 1. Wherever there is no oil or no gas or no any kind of pollutant matter, then you go with the type 2 exhaust hood. So these are the types of a basic canopy what we're looking at. They're wall mounted, single island, double island, back shelf, crossover, eyebrow, UV, water wash, and mist hoods. So these are the basic categories of what you're looking at in the exhaust hood. Now in type 1, all of this work is the same principal media, which is they filter out the oil from the kitchen equipment when it is going through the air. So let's understand them one by one. So first is wall mounted hood. Wall mounted hood is nothing but it is mounted on the wall. Now, it may say wall mounted on the wall, but it may be also set on the ceiling. The idea here by calling it wall mounted is that it is using a wall as a boundary. Now, this here, what happens is the cooking appliances flush towards the wall, thereby causing it to stick towards the wall so that you don't have any kind of draft created by the surrounding area. It has one of the lowest air requirement is because the wall acts like a boundary so that it doesn't allow the fumes to get disturbed by the movement of air around it. This has three sides which is finished, and it is one side, it is the wall. It is less susceptible to the cross drafts. Then you have an island hood or a single island hood, where you can see that the kitchen equipment is in middle and you have a hood operating right around it. Now the problem here, what happens is this is usually used in the display area or a so wherever the chef wants to showcase what they're cooking, like they want to show that they're making rotis or naans, or they're making grilled fish, or they're making
I think
Hello?
your voice is not audible.
Yes. Hello? He is muted. I don't know.
Mr. Anmol?
I think he's reconnecting.
Hello, sir. Voice is not able to hear, sir.
Yes, I think he's reconnecting. Yeah, his net issue.
Hello.
Yeah, give me a moment. Let us connect to the speaker. Just wait for 2 more minutes.
ஸ்லைடு மூவ் ஆகிட்டு இருக்கு ஆனா அவரு இதே இல்லையே நெட்ல இல்ல நான் ஃபோன் பண்ணிட்டே இருக்கேன். Yeah, Mr. Anmol.
Dear Nagavai, I can't hear at all.
Yes, we just, the speaker is reconnecting. Yeah.
Yeah,
Yes,
please.
connected.
Sorry for that. I'm just rejoining 1 second.
Yeah, we are discussing about the island type. From there onwards, there are some net
Yeah,
issue.
I'm just rejoining 1 second. Give me a second.
Yep.
Okay, I'll just share my screen.
அப்போ நீங்க தேங்க்ஸ் மெசேஜ் நீங்க பண்றீங்களா எப்படி அவர் விட்டு கேட்டாரு ராகுல் பண்ணிடுவாரு எப்படி கேக்குது.
Is my screen visible?
Yes.
Okay.
Now it looks
Yeah.
okay.
Yes. Yes.
Now it's clear, right? Yeah. My apologies, everyone. Let's go back to where we were. We were at single island, right? We were at
Yes.
single island, right?
Yes,
Okay.
yes.
So then you have double island. Double island is where you have back to back, where you have 2 kitchen batteries. You can see that the exhaust hood here looks like something like this, where you have 2 kitchen batteries over here. You have one which is a Lebanese section and one could be a Chinese section. So there are basically 2 types of kitchen equipment facing each other here. Okay. The problem here, what happens is, as I said, for island hood is that it is very susceptible to the fresh air around the hood. It can cause a lot of drafts created by it, so it can cause a hood to spill from the equipment around it. So then you have a compensating hood. Compensating hood is nothing but it's a double plenum hood where you have 2 plenum. One is an exhaust and one is a fresh air. So this exhaust and fresh air work in tandem with each other, where you have exhaust being sucking away the exhaust hood, and you have fresh air being supplied from the fresh air unit in the hood. So this requires the hood to have two plenums. You'll have one duct over here and one duct over here. So you have one duct over here and one duct over here. Usually what happens is you have 65% of the air being supplied through the hood. So in display area, what happens is you have an arrangement something like this, where you have a kitchen equipment hood back to back, you can see here, and you can see that the exhaust hoods are facing each other. Here what happens is you have a percentage of exhaust being happening here. So let's assume that there is a exhaust CFM requirement of 1000 CFM. So here what happens is in 1000 CFM, ASHRAE standard 154 says that the exhaust hood has to be at least 85% fresh air has to be compensated. That is, if I'm exhausting 1000 CFM of fresh air, 850 CFM fresh air has to be supplied into the kitchen working area. That is why it is necessary for us to do this calculation by terms of it. So that means how does it work is you have 60 to 65% being supplied through this area, in this area. Remaining 25% is being supplied from this working area. Okay. So type 2 hoods basically are something like this, where you have for ovens or for condensates. Usually what happens is wherever there is a cooking process which has no amount of oil, you go with the type 2 exhaust hood. So, like example, an oven hood, a rotary oven or a deck oven, it has mostly hot air exiting from the deck oven. That is why it is necessary for us to put a type 2 kind of hood. Same thing if I go with a dishwash section where I have the dishwash machine is generating a lot of steam. In that case, I go with a type 2 hood, which has removable baffles where the water condenses onto this plate and is drained out from here. Okay. So let's understand what exactly the sizing comes. Basically, what happens is the hood has to be bigger than the kitchen equipment. The reason is because whenever the fume starts to generate, it becomes bigger and bigger and bigger. That is why the best way to design an exhaust hood is by creating the tip of the kitchen equipment to at 12 degree angle from it. And at 2100, that should be the inner surface of your exhaust hood. That means from the kitchen equipment, I am drawing a tangent of 12 degrees, which will be the inner surface of the exhaust hood. That will be the overhang of the exhaust hood or the depth of the exhaust hood. Now, the lower the cooking surface, the more should be the overhang. That is, if I have a low kitchen equipment, my overhang will become higher. Okay. The reason we do is because, as you can see over here, at 0.8 meters, that is at the kitchen equipment level, or the kitchen equipment is usually at about 3 feet of the exhaust hood. That is where you will see halfway between the exhaust hood and the kitchen equipment, the plume has become bigger, or the convective plume what is generating out of it is become bigger and bigger. So you can imagine like a mushroom cloud kind of thing coming out of this kitchen equipment. That is why we need to have an exhaust which is bigger than the kitchen equipment surface. Okay. So why we need to do this? You can see that example over here. I have a kitchen equipment over here and I have an exhaust hood over here. You can see that the fume is generating a lot of it from this kitchen equipment surface. But what is happening is because it is smaller, it is causing a lot of spillage. You can see all the gas is starting to spill out of here. That is why if you don't do proper overhang, you'll have a lot of spillage coming into the working area. That is why whenever you're doing a design, you need to understand what kind of model you're working. Are you working with a capture model or are you using a spilling model? If your design is properly done, where you have enough overhang, if you have enough overhang, it will cause the only convective heat to go into the equipment and only radiative heat to come out of the equipment. Same thing, if I have a spilling nature, what happens is I have both convective heat and radiative heat coming out of this cooking surface area. So what happens here in the compensating? I create an air curtain in front of the hood which supplies air with a very low velocity in front of the hood. So what happens is this creates an air curtain. You can see a small line over here, right? This is creating an air curtain. So what happens is when you use a compensating hood for air curtain purposes, this creates a sort of a boundary around which it doesn't allow the fume to come out of kitchen equipment. So how to design a kitchen exhaust hood? 3 things are very, very important. First is capture, contain, and exhaust. Capture is it has to have good overhang. It has to have good overhang. So whenever there is an overhang, lack of it, it will have a problem. So always remember, whenever doing a kitchen ventilation project, if your kitchen is having some kind of issue, that is your smoke is spilling into the working area, then one of these three parameters has been compromised. Always remember, as per ASHRAE, kitchen has to be in a negative pressure, not in a positive pressure. Kitchen has to always be in a negative pressure. That is why we exhaust 1000 CFM and remove supply back 85% of it. Okay. Second is containment. You'll see a lot of images on Google or on website where you'll see the exhaust hood tends to be in a very tapered form. This tapered form is a very bad idea. The reason is because this internal area, what I'm looking at, this internal area, that is where my container of my fumes happens. Container fumes happens. And if you don't do this, what happens is this causes the fumes to exit of the kitchen equipment. Victor, I see that there's some call in 15 minutes, so I'll ramp a little bit faster.
All right, sir.
Yeah. So then you have effective exhaust filter area. That is, if your filter area is not good enough, you will have a lot of problems in the kitchen equipment surface. That is why you need to plan your exhaust in such a way that all these three are taken into consideration. So what do you mean by overhang? As per ASHRAE, it says that for a wall-mounted hood, you need 6 inch on the side and 12 inch in the front. That is, if my kitchen equipment is say L by B, then I need to add 6 inch on each side and 12 inch on the front side. If there is a wall over here, you can eliminate the 6 inches over here. But in case of an island hood, I have to have 12 inch overhang on all of the other sides. So how do you optimize CFM extractions? You either increase the overhang for a larger containment of exhaust volume, or you provide compensating hoods which provide an air curtain for the exhaust hood to avoid spillage. Okay. So exhaust blower. Basically, in all our house, we have seen there is an exhaust propeller fan like this. Now, small restaurants tend to go with these kind of axial blowers because it is very cost effective for them. Then the problem what happens is the actual requirement is not met by these kind of blowers. You have to have these kind of centrifugal blowers. That is why the reason we tend to go with single skin SISW fans is because of centrifugal blowers are much more rugged. They're much more compatible for kitchen ventilation systems. So what are the nature I need for this kitchen blower is, it has to be in a load limit nature of a fan. It has to be self-cleaning orientation of the blade and a higher static capacity and high efficiency fan. Usually here what happened is we are looking at three parameters of a blower for this, which is it has to be backward curved inclined fan. It has to have self-cleaning nature, that this backward gives us self-cleaning nature of the fan. Second, it has to have high efficiency and high static capacity or high static pressure requirement in this case. So we have moved with the evolution where we have moved a mixed flow fan where you have an axial flow fan and a centrifugal fan. Mixed flow fan is this, where you have a mixed flow fan, something like this over here. So makeup air units in India and other areas, you will see that there's a lot of usage of these kind of system where you have a makeup air unit where you have evaporative or cell deck pad being used for cooling media. Now the thing what happens is if you use TF in the system, you have here a very high tonnage. So you have to compromise somewhere on cost versus efficiency system. That is the reason we go with a IDEC or a evaporative air cooling system. Now what happens if you have too much cold, your food will tend to become cold. That is the reason we need to have a proper understanding of what is going on here. Okay. So basically here what happens is your kitchen equipment surface are also utilizing these kind of IDEC or indirect evaporative air cooling, where you have a second media in between, which is not allowing the latent heat to increase in the system. All of us understand about latent heat, right? So whenever there's a direct mixture contact between air and water, there is a latent heat addition which is happening. In this case, because of this medium, it doesn't allow the temperature to increase. Okay.
Mr. Anmol?
Latent. Yeah.
Yeah. One quick announcement. We have one new link actually, because this link will get expired soon.
Okay.
Once this call may end, we can join in the chat box. We have given the link. Actually.
Sure, I'll do that.
This is for all the participants as well. Yeah. You can continue.
Yeah. So here what happened basically is that whenever you have a makeup air system, you have these kind of system where you're using a indirect evaporative air cooling system here. Okay. So the beauty of this is it is right in between the evaporative air cooling and TFA system, the cost wise and efficiency wise both as well. So let's come to compliances. As per NFPA, it says that you have to use MS ducting for the exhaust ducting, which is for a kitchen ventilation system, an exhaust ducting has to be MS or SS. What grade should it be? It should be 16 gauge for MS or 18 gauge for SS. Please remember this very, very carefully. Exhaust ducting has to be MS or SS. it has to be 16 gauge MS, or SS, it has to be in 18 gauge. Okay. The reason is because if it is a GI duct, it can melt because of a lower temperature and it can deform, causing a lot of life loss. The reason NFPA says that it has to go with a MS or SS ducting. All this ducting sealing has to be done either full welding, that is you do welding on edge welding or butt welding, or you have to use a UL listed fire proof gasket or a sealant. Okay. Now coming to quality of discharge. Now the thing about Middle East is that they are very, very stringent on their quality of discharge. That means whenever there's an exhaust being done in a kitchen atmosphere, it has to treat the air which doesn't allow it to be thrown out. In India, it is less more stringent. That is the reason understanding what is happening here is very, very important. So first thing is we go with two types of filtration system in a discharge air. That is our scrubbers, which are used for scrubbing the oil in the system. That is, whenever I have a scrubber unit being placed over here, it removes the entire oil which is happening over here. A scrubber is majorly used for removing oil and ensuring that there is no amount of oil going beyond the scrubber unit. Now, one major thing which happens over here is that a lot of people make the mistake, which is they do not put the scrubber unit as close to that as possible. You can see an image what I've attached over here. The scrubber unit is very, very close to the hood. The reason is because the closer the scrubber is to the hood, the more efficient it is. Now, what happens is your exhaust hood has to work at an efficiency of 80%. That is, your baffle filter inside the exhaust hood, what's the 80% efficiency? The remaining 20% tends to go and get deposited into the duct. Now, what happens if you put an ecology unit at the top of your building? All the duct will get corroded with oil, but no amount of oil will end up in the scrubber, and you will assume that your scrubber is working full capacity or full efficiency. That is the reason you should have a proper notation where your scrubber has to be as close to the hood as possible, Okay. So the reason we go with dry scrubbers because they are very, very efficient. They're about 90 to 95%. They have very low pressure drop across the filter area, which saves power. Unlike wet scrubbers, dry scrubbers are very, very efficient. These electrostatic cells are very, very capable for long life by proper maintenance. It can manage to filter up to 0.01 micron. And there's a very low power consumption of 50 watts per every 3000 CFM. There is no consumable required of here. There's no oil free also requirement here. So this is why people generally go with a scrubber unit in system. Then you have UV. UV is a new type of generation of filtration system where you're using a UV lamp for destroying the oil, grease and other pollutants. Now please remember, UV and scrubber can only destroy oil and grease. It cannot remove the gaseous content. That is why if the pollution control says that you need to also filter out gaseous substances, you also go with a different filter media for that is carbon filter or other kind of media. Now UV, what happened is UV is nothing but an ultraviolet radiation. This is a very, very high ionizing radiation. What happens in this is that it does two things, which is photolysis and ozonolysis. What photolysis is by the media of its own light generation, it destroys the oil and grease. Now, oil and grease is nothing but a hydrocarbon, and this hydrocarbon, when it is exposed to very high radiative energy, it breaks down into carbon and hydrogen. Now, second thing what happens is this UV lamp generates a lot of ozone. So this ozone tends to go and react with this carbon and hydrogen atom and creates CO2 and H2O. That is why this does not allow any amount of oil to go beyond the exhaust hood. It also removes completely odor and also ensure this doesn't have any kind of requirement of cleaning. The only thing about UV lamp is that it requires a yearly maintenance of removal and substituting a lamp. That is, there is a replacement cost of this UV lamps. Okay. So let's come to the design standards. In design standards, we are usually following ASHRAE, BISA or VDA. ASHRAE is a very well-known industry standard. BISA is more European, VDA is more German standards. Okay. So DW172 says that there are different type of kitchen equipment here. You can see that there is a pasta cooker, there is a tandoori oven, there is a pizza oven, etc., right? So here what happens is, based on the type of kitchen equipment surface, that is, if the kitchen equipment surface is 3 feet by 3 feet or 900 by 900 or 0.9 by 0.9, to calculate the CFM of exhaust, we do the multiplying factor over here. That is, we find out the area of the kitchen equipment surface and multiply with the type of kitchen equipment available over here. That will give us the meter cube per second volume flow rate required for the exhaust of this kitchen equipment. Okay. Same thing, if I'm looking at ASHRAE, I have different type of process. You'll see that ASHRAE has light, medium, heavy, and extra heavy. So you'll see that oven are a light duty equipment. Same thing for a range or a griddle or a fryer, it is a medium duty. Heavy is when I'm using a broiler, a grill, or a range, or a wok. Same thing, extra heavy is when I'm using solid fuel appliances like tandoor, sigdi, shawarma, etc. Those kind of machines. Okay. So standards depend on the type of cooking operation you're planning to do. Okay. So in case of DW160, you go with the area of the calculation. Here, actually say that you have to follow these equipment for the calculation CFM part. So what happens is when we're doing a design, as I said earlier, you need to take the equipment design first and then calculate the CFM of the exhaust hood by calculating the size of the exhaust hood. That is, if your kitchen equipment size is known, you find out the exhaust hood size and then you multiply a factor of the length in terms of the CFM. That is, if my kitchen equipment surface is say 7 feet by 3 feet, my exhaust hood ends up becoming 8 feet by 4 feet. In that case, if I have tandoor underneath the kitchen equipment surface, for a wall-mounted canopy, I go with an extra heavy. That is 350 CFM into 8 feet. That is how I calculate the CFM of the exhaust hood. Same thing if I have different type of kitchen, like if I have a light, medium, and extra heavy all mixed in one category, I tend to go with the average of all of these calculation CFMs. Okay. So this is usually used for our type 1 hoods for our as per ASHRAE. So coming to BISA, BISA has different standard. It says you have to follow a different standard where it says follow VDI, but it says that you have to have makeup air has to be 70 to 95%. It cannot use any kind of diversity. Vapor would be necessary for dishwash sections. It says CO also has to be properly maintained, where you need to have CO monitors and detectors to be placed in the kitchen working surface area. The temperature in the kitchen cannot be more than 28 degrees Celsius because radiative heat has to be maintainable. Same thing, it says you can go with 60 air changes or you can also go with 120 air changes, but preferably always go with the 60 air changes system. Okay. Then it says for cold room, it says that you have to have individual extractor dedicated supply for the compressor location. In case of compressor of a cold room, it generates a lot of radiative heat. That is why you need to have a grill or an exhaust fan on top of it where you can remove that hot air from the area. Same thing for dry store, it goes with 10 air changes. For preparation areas, it goes 20 air changes. Server, it goes with 12 air changes. Chef's office, it goes 6 air changes. And wall lock kitchen, you should have at least 10 liters per second movement of air in the system. Then you have hood positioning. It says that the minimum distance between the kitchen equipment surface, that is, it should be 450 mm. It cannot be less than 450 or 18 inches. Lower level canopy can be 2/3 has to be covered. That is, if the equipment type is a lower level canopy type, it has to cover at least 2/3 of the kitchen equipment surface. The minimum height of the hood has to be minimum 400 mm. Again, BISA and ASHRAE work on two tandems here that they say that the hood mounting height should be 2100 mm from the FFL. But if you decrease or increase the level, for every 100 mm change in the height, you have to increase the overhang in the same value. That is, if the front overhang of your hood has changed from 600 to 500 to 400, for every 100 mm increase in the depth, that is the height of your exhaust hood, you need to increase the depth of the exhaust hood. In this case, it says that you need to go with 250 mm in the front overhang and 250 on the side. Unlike ASHRAE, which has 6-inch and 12-inch on the sides, BISA says that 250 and 250 should be on all sides. Okay. I've concluded just in time. Let's do one thing. Let's join back in the different link so that we can have a Q&A sessions. Okay.
Mr. Anmol, if you don't mind, can we join in the other link?
Yeah, I think he went to join in the new link. Yes.
Yeah. Okay. Okay. Let's everyone join in the new link. We'll go for the question and answer session and quiz program.
मुंबई वाले ओला
ஆமா ஆமா ஜாயின் பண்ணிட்டு வரேன். ஓகே வந்துட்டார். ஓகே.
So I hope all of us had a proper understanding. My apologies for the delay in the scheduling part because we suddenly disconnected because of some issues. So any Q&As, please let's hash it out over here.
Yeah, I have a couple of questions.
Sure, Ragan, please go on.
So I have an experience of selling ecology units, kitchen ecology units for the kitchens. And
Okay.
I have two questions. Okay, why we required makeup air handling unit for kitchen hoods, and how to estimate the fresh air requirement for kitchen hood?
Okay, excellent question, Raghavan. So as per ASHRAE, it says that if I have 1000 CFM of exhaust, I need to provide 85% of the fresh air in through the hood. Now, the reason we provide fresh air in the hood or makeup air in the hood is because, or in the kitchen is because, if you do not provide fresh air into the system, two things will happen. One is your staff will feel very uncomfortable because the gas is continuously using oxygen for combustion, and thereby the oxygen content in the kitchen atmosphere is going slower, lower and lower. Thereby it creates very, very drastic effect on the kitchen equipment of the surface of the people around it. That is why it is very necessary to have fresh air being supplied through the hood. To answer your second part, depending on the type of kitchen atmosphere, that is based on the optimization, we have to go with either 80 to 90% of the fresh air. Now, as you ask, makeup air through the hood, depending on the type of budget of the client as well as the efficiency of the system. If I go with a SI single skin or a single plenum exhaust hood, there what happens is I need to provide fresh air in front of the hood so that it creates an air curtain around the hood. Here what happens is a double plenum hood directly creates a air curtain in the form. I'll just show it in the slide once again. Just a second. Yeah. So let me share my screen. Yeah. So I'll just go there. See, what happens is in a single island or hood here, what happens is that I need to provide fresh air right in front of it. So thereby what happens is the fresh air is very, very direct in front of it. Now, same thing if I go with the compensating hood, what happens is this compensating hood will generate a very low velocity in top of the chef or at the bottom of the hood, which creates a proper comfortable atmosphere for the staff to work in. At the same time, it provides fresh air in front of the hood, which creates a positive pressure or a cold spot around the kitchen equipment surface. That is why the chefs feel very, very comfortable while working. If I don't do that, what happens is the chef will feel the air distribution is not enough. It will create a lot of hot spots in the kitchen. So I hope I've answered your question, Raghavan.
Yeah, just to have a few more clarity, like say for example, customer has an data for exhaust airflow and he has the hood size. So how do we, is there any standards by ASHRAE or ISHRAE like?
Yes. So ASHRAE standard 150. Yeah, ASHRAE standard 154 is the one which you need to look for, the kitchen ventilation standard. So ASHRAE standard 154 gives you this calculation sheet. One second. Yeah, so it gives you this calculation sheet where you design the CFM based on the type of kitchen equipment underneath the hood. That is it a light duty? Is it a medium duty? Is it a heavy duty? Is it extra heavy duty? Once the type of hood and the size or dimension of the hoods are clarified, then you go with the CFM calculation. That is, if I, as I give an example, if I have an 8 feet long hood or a 10-meter hood, in that case, what happens is I do the CFM calculation based on the type of kitchen equipment underneath the hood. In that case, my CFM calculation will happen over here. So if I have say 8 feet hood, 850 into 300 CFM, I get a 2400 CFM as my calculation of my exhaust would then. So 2400 is my exhaust. Same thing if I want my fresh air, I multiply it with 0.85 or 85% of it. That will be the fresh air of the system in the area. Okay.
Yeah, perfect. Coming back to the second question,
Yeah.
in the exhaust, we use, I have seen your slide, SISW fans for the ecology units in the exhaust.
Correct.
Why
Yeah.
not with DIDW with fire rated fans or fire rated motors?
That is also a good idea. Depending on again, it comes back to the budget and the requirement of the client. If they say that I want to go with an ecology unit which has a DIDW fan, we can go with it. But it has to be one thing which has to be very, very clear is that the motor stream, the motor has to be outside the airstream. It cannot allow any kind of oil deposition to happen on the motor. If the motor hub is properly connected, it has to be done with proper orientation or a extended shaft so that it doesn't allow the oil or hot air to go over the motor hub, thereby causing it to become hot and burn out. So life of the motor goes on drastically because if the environment we will be working in creates a lot of hot air, and this causes the life to go down drastically because of this. So preferably, I would go with a SISW fan, but they tend to be much more rugged. But the thing what I observe in DIDW fan is if they're not properly designed, that is, if the make is not properly given, it tends to deform under the high static pressure capacity. So it depends on again the client, as I said.
Still, I need some more clarity to be so like even like the motors will not have an experience of much pressure and much high temperatures, and the oil also gets arrested in the ESP, but still the motors
Yes.
can be still preferably to work with DIDW. This is what my understanding. So is there any standard like only the DIDW?
No, there's no specific standards for that. Actually, AMCA both have been very clear about that. But as I said, it depends on the type of application what you're working with. Because in the case scenarios where you're working with heavy duty, like we have found a lot of areas where the DIDW fan has a belt drive, and this belt drive, if the scrubber in it is not being properly maintained, there will be a bypass of the oil into the blower area. And thereby what happens is the oil tends to get deposited onto the motor hub, the belt drive, and the system as well. So thereby it causes a lot of heat as well as the breakdown happens very, very fast. So that is why we prefer to have an SISW fan where the motor is outside the airstream so that it's much more easy to work with. But then again, as I said, it is purely depending on the type of client's understanding. DIDW fan are good in nature, but as I said, it is depending on the type of, as I said, fireproof. There are specific fans designed for these. Plug fan is also applicable for these kind of systems.
Yeah, perfect. It's very nice explanation. Actually, I had a lot of questions on this. Actually, now I got a perfect answer. Thank you so much.
Thank you. Any other doubts? Please feel free to ask.
Hi, my name is Ansil. Thanks for this brief of kitchen ventilation. We all know this is a critical space, kitchen area. So my first question is, which type of fan would you recommend for the kitchen appliance? I mean, kitchen application where we have multiple hoods, like hood codes. Do you recommend VFT or we can go with the constant speed fan?
I'm sorry, your name is Senthil?
Ansil.
Okay, sorry, Ansil. What happens is, it depends on the type of working of your kitchen you're working with. See, in areas where I have a restaurant where I have a fixed timeline, that is at 4 o'clock in the morning, my preparation starts. By 9, my food preparation starts. So the process of preparing the food and the actual cooking process will have a deviation here. So in that case, you can go with a VFD to save power, to save energy, to save your cost as well of your running cost. But in case of areas where I have continuous operation, like a central kitchen or a hotel kitchen where it is working for almost 18 hours of a day, in that case, it doesn't make sense to go with a VFD because, again, it depends on the budget of the client as well. If the client says, I want to go with a demand control ventilation where my system is integrated with a demand control system where based on the type of operation happening underneath the hood, it will go, the motor speed will elevate or, decrease or increase. Preferably, coming to one specific instance is that what I talk about the motor is that it has to be SISW or DADW with backward curved fans. That is, it has to be backward. It cannot go it forward. That is number one. Number two is, if you're going with a VFD, you have to properly utilize a VFD. A lot of places, what you find is they have a VFD in the blower, but nobody utilizes. You're just burning power for no reason of it. So if you are going to use a VFD for some specific application, like you can use a time-based operation for your kitchen. Like if you have a chef on board or a facility manager on board, he says, I know what time the cooking operation starts. I know what the time of cooking operation ends. In that case, you can go with a time-based operation. You can also have a demand control ventilation where you can have these VFDs linked to the sensors, which will modulate the blower based on the type of demand at the kitchen equipment surface. Yeah.
Yeah. The problem is, as I mentioned earlier, this is a food court. We have a multiple kitchens with different operators. Okay.
Okay.
So
okay.
in that case, if I go with the constant speed fan, maybe sometime some operator won't operate at the same
Correct.
time. So in that case, you will have a huge amount of exhaust is taking out
Yes.
from the
Yes.
kitchen node where it is not operating, and
Correct.
same fresh air is coming to the kitchen. Maybe I experienced in India, most of the people are not using treated fresh air. So we will have a
Correct.
huge amount of fresh air is coming without operating some of the operating hoods.
Correct.
Okay.
Correct.
So
Correct. Correct.
that case, I think constant speed fan will
Are
make
not worth
extra.
it. Yeah.
Yeah.
Rightly said. That's what I said, Insan. In this case, what you can do is you can go with demand control ventilation, where wherever there is demand, only that area suction will happen. So what happens is, suppose I have a food court. If I have 10 food court outlets and only 4 are operating, so wherever there is operation happening, only that much CFM gets utilized for the blower. But same thing, I can utilize it in my kitchen equipment surface where I'm working with, say, a hotel. In a hotel, I have different batteries. Like I have a Chinese section, I have an Indian section, I have a Lebanese section, I have a Tandoor section. Now, in the morning, only one section works. But at the noon time or the dinner time, all sections work at the same time. So thereby what happens is I can modulate the blower based on the type of CFM requirement is. In case of food court, as you rightly said, you can go with the demand control ventilation where it modulates based on the type of operation which is happening in the one of the outlets.
But again, sorry. We will have a main centralized duct only. So how do we gonna control if I have?
So in that case, what happens is the exhaust hood has to have something called a modulating damper. If you don't have a damper in place, it doesn't modulate the blower speed. What happens is right near the damper, it has a sensor, and the sensor modulates and sees whether how much CFM is coming and how much heat is coming out of the kitchen equipment surface. For example, I have like multiple people use smoke and it will tell there's cooking operation happening in this area. Switch on the blower at full speed. Some areas it says it will have a thermal sensor. So this thermal sensor will measure the temperature of the air in the duct, and it will say, okay, here I have cooking operation happening. So switch on your exhaust hood or switch on your blower full speed. So depending on the type of operation is happening, we need to modulate the blower. But as I said, if you don't have a demand control ventilation in place where you don't have a VFD, blower with a VFD, sensors in the system, and also a modulating damper, it is very, very difficult to work with that. Okay. I hope you answered your question, Ansel. Okay. Any other doubts, please? Please go ahead.
Sorry, I lost my connection.
No problem. How much part of it you got it?
Hello.
Yeah, Ansel, please tell me.
Yeah, I'm having one doubt.
Yeah, please tell me.
How to calculate the exhaust CFM? That's I didn't understand. Can you explain once again?
Okay, I'll explain once again. So what happened is, first is example of this. Okay, I have given 3 ranges over here. Okay, 1, 2, 3. Suppose this is 3 feet by 3 feet. Okay, 3 feet by 3 feet. So what's happening here is my hood length is determined by the type of orientation. Is it a wall mounted? Is it a what kind of orientation is it? So suppose this is 3 feet by 3 feet. So 3 feet is the depth and 3 feet plus 3 feet plus 3 feet. So 9 feet by 3 feet is the length of my kitchen battery or kitchen equipment surface area. So what will happen? My design over here comes is that I put 6 inch on this side, 6 inch on this side. So 9 plus 16, 16 becomes 10 feet. My depth is 3 feet plus 12 inches. So it becomes 4 feet. So now the dimension of my exhaust hood is 10 feet by 4 feet. Okay. 10 feet by 4 feet. Now what happens is I go over here where I come to the calculation sheet where I look at the type of operation of my CFM requirement here. That is, if I have a range, if I have a work range or a normal range, in that case, what happens? I have a heavy duty, that is heavy duty CFM calculation requirement, CFM requirement. So there I go with heavy duty wall mounted. So my hood length is 10 feet. So 10 feet means 200 by 400. So I can take 200 CFM. So 200 CFM into 10 feet, I get 2000 CFM of exhaust requirement. Same thing, 2000 into 0.85 will give me the fresh air requirement in the same area. Okay. Is that clear, Abhishek?
Yeah, it's clear. Thank you.
So that is how you first need to get the kitchen equipment layout, and then you can do the CFM calculation for it. So as a HVAC engineer, you have to ask any kind of project you're working with. If you do not have the kitchen equipment layout, it is very, very difficult to calculate CFM. Okay.
Yeah, okay, thank you.
Any other Any other doubts?
Sorry, Anmol, I lost my connection. Can I come back?
Yeah.
Yeah.
Yeah, please.
So I think
what
that
I'm
was.
saying,
Yeah. Please.
what I'm saying, Ansel, is that when you have when you're using a food code, what you can do is you can go with the demand control ventilation, which has multiple sensors and multiple modulating dampers. So wherever there is an exhausted requirement, the damper will open by the sensor giving information to the blower. Now, example, I have a pizza area, I have a Chinese section, I have a frying section. Suppose in the morning only it's working. So there what happens is only that much CFM of exhaust is taken out and remaining all dampers are closed. Only that area, the damper fully opens and the CFM increases based on the type of requirement of the working area.
Dampers are allowed as per NFPA?
You need to use fire dampers in the duct, but near the exhaust hood, you have to go with a damper, VC damper, which is UL listed. Okay, UL listed.
Same time, even we are using modulating damper, we will have a constant speed fan itself, right?
No. You can go with a what you call variable speed motor.
2-speed?
Yeah, variable speed. Yeah. Okay, you can connect with me later on this answer.
Sure. I will. Yeah.
Any other doubts?
There is gaseous type ozone generator are available. You are saying about UV light type. So which one is better?
In case of filtration of fumes, UV is much more efficient because it removes oil, grease, and odor as well. But in case of scrubber or your ecology unit, it only removes the oil and grease in general. Unless you don't have a UV lamp, it will not eliminate the odor. That is why UV lamp is preferable to all of them. But then again, the UV lamp has to be inside the hood with proper safety features. If you don't have safety features, you'll have a problem with this. That is where for exhaust hood, you have to go with UL 1046 and UL 710 for this kind of system approach. Yeah.
Okay. Also, one more question. For
please.
the ecology unit, I have a project. The ecology unit is like at roof, 15th floor. It's a roof. So you are saying it should be as close to,
Yes. See, what happens is in case of exhaust hood operation, 80% of the oil is removed at the filter level, at the backfill filter level. The remaining 20% ends up going into the hood and then into the duct. So this 20% has to be properly removed. So what happens is when you put an ecology unit at the top of your building, the entire oil is deposited onto the duct. Okay, so thereby all your oil will hardly reach your ecology unit. So you will always assume your ecology unit working 100% right, because you don't have any kind of oil reaching the ecology unit at all. That is why the ecology unit has to be as close to the hood as possible, like I've shown here. or the scrubber unit has to be as close to the hood as possible. In India, the issue is we have a lot of lack of heights in kitchen areas. That is why people tend to go with a ecology unit on the rooftop. But wherever there is height opportunities, you can go with these kind of system over here. Yeah.
All right. One more question. Fire damper is not required for the kitchen ventilation
It
system.
is. In as per NFPA and UL both, you have to go with the fire damper for the exhaust ducting.
Any kitchen duct passing through the fire rated wall. It requires
Yes, it has to. Yeah, it has to go with the fire. That's correct. Rightly said. Any other doubts?
Sir,
Yeah,
is
please.
there any maximum minimum velocity for the exhaust and the fresh air duct?
Okay, so again, this is where there's a lot of deviation between India, Middle East, US, XL market. NBC and NFPA says you have to have minimum of 500 FPM in the exhaust ducting. Maximum can go to about 2,400 FPM. India, it says you have to work with 1,500 to 1,800 FPM. So it depends on the type of compliance you're working with, because ASHRAE, SMACNA, so there's a lot of difficulty over here, because ASHRAE says something, SMACNA says something, NFPA says something, and the local board says something else. So it becomes very, very difficult for you to calculate based on it. But always I would say follow ASHRAE, SMACNA as close to the bill as possible, with compliance with the local norms in your country. Yeah.
Okay, sir.
Any more questions?
Yeah, one more question. When you
Yeah,
said
please, Anmol.
about the compensating hoods, the fresh air will be thrown to down. It will be down to vertically downside, right?
In this case, like what I'm saying is this. Yeah, in this case, the fresh air is coming both in down and in the front both as well. It is called a makeup air or a compensation. Yeah.
Yeah, but when it is coming from top to down, like vertical, the operator is facing, like, in the Middle East, the fresh air in the summertime, it's very hot. So operator is facing,
That's right. This fresh air has to be cooled in some form. That is, you have to either supply TFA or you have to supply some kind of. This is what I said. Either you can supply this evaporative air cooling or IDEC system where you are providing fresh air at 28-30 degrees Celsius, and you have a TFA over here which is supplying at 14-16 degrees. So these both mix together and you have a proper temperature 24 degrees in the kitchen working area.
Yeah, noted.
Okay. Yeah.
I think it's already time, and any more questions, you can directly send it to us. We can reach out to the speaker, and then we can get you the answer actually. Yeah. So thank you so much, Mr. Anmol. Your presentations were very crystal clear, and it was more insightful. So I extend my heartfelt thanks to everyone who has joined us for today's insightful webinar on kitchen ventilation system. A special note to appreciation to our distinguished speaker for sharing in-depth expertise and real-world insights and practical knowledge of kitchen ventilation system. Your presentation sparkled valuable discussions and deepened our understanding of kitchen ventilation. To all participants, thank you for your time. And we will have a small quiz program on what we have. And then we can have some certifications, other stuffs during this time. Victor, can you take a lead on this?
Yes, once again. You see my screen?
Yes, we can see your screen.
You can see this one. Can you, did you see my QR code?
No, Victor, we can only see your screen. I think you shared only your window, not your screen.
All right, one second, I'll share again. What about now?
Okay. Our industrial நம்ம சொல்லிடலாம், இது முடிச்சிருங்க அப்படி. ஐயோ, இல்ல
Yeah, now it's clear.
Yeah. Can you,
Just
can
to
you, yes.
give a small brief, like we used to have a question and answer session, like so that the participants also will be more interested in the presentations. And what are the topics we covered, we usually ask the question and answers basically, so that we check, we evaluate who has answered all the questions, and we give a certifications.
And also we have the link is in the chat box. So whoever are not able to scan this QR code, you can go to the chat box and scan, click the link and then answer it. So do you want to say anything about?
Sorry?
Do you want to say anything?
No.
No problem, sir. Thank you so much, sir. Once again. If you want, you can leave, sir. Thank you so much.
Yeah. Okay. Thank you so much.
Thank you, sir.
You can share my details with them and they can reach
Yes,
out to me.
sure, sure, sir. We will put it in the LinkedIn and then the YouTube channel.